Okay, so let's talk a little bit about chemical equations. So a chemical equation actually is a shorthand for describing a chemical change, or this is also called a chemical reaction. Okay. Now if you look at it, if I say aluminum reacts with iron 3 oxide to form iron and aluminum oxide upon addition of heat, this is called a word equation. And we've seen this before. However, now let's do our shorthand. And when I say aluminum reacts with iron oxide, what that means is aluminum and the iron oxide are what we start with. And to form, that means something's happening. And then what do we have at the end? Iron and aluminum oxide. And we have to add heat, so we're going to put this somewhere into our shorthand. So let's write our shorthand on the bottom. And the shorthand will look like this. Aluminum, okay, Al, that's my L, reacts with, so we're going to add iron 3 oxide. So the charge of the iron is 3. So I would spend time if iron 3 oxide is a 2 minus. I'm going to crisscross them. You're going to get Fe2O3. Okay, forms, right? Because you're saying to form. Now I'll erase my work here. You'd have scratch paper. I just don't have enough space on this board. But you'll have scratch paper as you write everything out. Aluminum oxide, that's metal, non-metal, so we know it's ionic. Aluminum, the ion is Al3+, oxide is O2-. So again, if we crisscross, you get Al2O3, okay? And iron, okay? Does it matter if I put the iron here or here? The answer is no. You have to have them both on the right side of the arrow. So before we continue with the heat, let's go through and describe this a little and talk about some of the concepts that are going to be involved with this. Okay, so when we look at this, this means to form or produces. Okay, this is what we start with. So these are called reactants. They are always on the left side of the arrow. And on the right side of the arrow, these are like products. These are called products. Okay? Now this is essentially a recipe. If I were making, the other day I made strawberry rhubarb pie for the first time. I'm so proud of myself. So when I put together all of my ingredients, those are my reactants. After I put them, mix them all together, and I put them in the oven, then basically that's like the arrow. I am forming or producing, and on the right, my product would be a strawberry rhubarb pie. So this is just the shorthand for saying what we're doing. We're starting with reactants, mix them together. In this case, we're adding heat, and then at the end, we have something new, and those will be our products. Okay. So if you look at this, what's interesting is I start off with 1 aluminum, but I end up with 2. Well, that's not possible. Okay, how do we know it's not possible? So remember when we were talking about Dalton's theory and the law of conservation of matter? Okay, so let's go through both right now. So, the law of conservation of matter, okay, or you could say of mass, so I'll just go say of mass, okay. It means that you cannot create nor destroy mass. Okay? In other words, the sum of my mass here, when the reaction is done, must equal the sum of my reaction here. Okay? Why does it have anything to do with what we're looking at in terms of our reaction? Well, the other aspect that we need to keep in mind is this. Not only can we not create nor destroy mass or matter, okay, the other part is that in a chemical reaction, okay, you cannot change an element. It only recombines to form a different substance. Okay? And we see this when Dalton put it as one of the postulates that he used in order to derive the atomic theory. So in other words, if I have an aluminum on this side, on the reactant side, that means I have to have an aluminum on the product side. But I can't convert one of these irons to aluminum and have only one here. So I have to figure out, how is it possible if I can't create or destroy matter, and I see that I have one aluminum here, two aluminums in my products, two irons here, and one iron in my product. How do we satisfy these laws? And so what we do is we say we have to balance the equation. So what we need to do is balance the equation. In order to satisfy these laws. Okay? So how do we do that? By using coefficients. Now, why not the subscripts? Okay, because already we know why the subscripts are there. To get a neutral compound, I must have 2 aluminum 3+ ions and 3 oxide ions. So I can't change the subscripts. That would change my compound. So the only thing I can do is to add coefficients. Like our subscripts, if I have a 1, I don't need to write the 1 in front. By merely writing the symbol, I know I have 1. But anything else, you're going to write here. So how do we do this? Well, we basically do a count. I have 1 aluminum. I have 2 irons. Okay, and I have 3 oxygen. So let me just scooch up here. Okay, on the right hand side, I have 2 aluminums, 1 iron, and 3 oxygens. So I'm not going to do anything with my oxygen. Those are fine. So what I'm going to do is, you're going to try to leave your elements for last. Now why is that? Because see, they're standalone, so if I change the coefficient here, I don't have to worry about changing more coefficients. So we usually work from the most complex to the least complex. I have 2 aluminums and I only have 1 here. So let's take care of my aluminums. If I put a 2 as my coefficient in front of aluminums, that means I have 2 aluminums, not 1. That means my aluminums are done. Here I have 2 irons, but I only have 1 iron here. So I'll put a 2 in front. That means I have 2 irons. That means my total is going to be 2. So I'm okay here now. And my oxygens are okay. So now, by using coefficients, I can satisfy the law of conservation of mass. I haven't created or destroyed any mass. And I balanced it so that what I start off with the same number of atoms of each element, I end up with. But they're combined differently And that's how we get our new substances. So the last part, or two parts, is this. Okay? What we have to do is we have to add heat. So when it says upon the addition of heat, this triangle above the arrow, this means heat. I'm adding heat. Okay? So that's what the triangle means. Now, this part, you're not going to know automatically unless I write it in your word equation. Some of them you will know, but in this case you won't. And that is, how high of a temperature is this thermite reaction? So aluminum, we know, starts off as a solid. And then this is going to be solid. It's an ionic compound. Okay? When you actually heat it up and this reaction occurs, you form a solid here, but the iron actually is molten iron. So, what are all these symbols? These are our physical states. Okay, so S means solid, L means liquid, okay, G means gas, and AQ means aqueous. In other words, the substance we're looking at has been dissolved in water. Okay? So what happens, let's say, if I started off with, in this reaction, I started off with, in total, 250 grams of reactants. It turns out if it goes to completion and I'm completely done, or even if it doesn't go to completion, if I look at that flask and I haven't done anything with it, I will end up with 250 grams of products. And that's because of the law of conservation of mass. Okay? So let's talk a little bit more now that you've seen your chemical reaction, why we can balance it, and how we balance it. Let's go through and practice balancing equations.